Hello viewers, welcome to my channel. I'm Hasham Ali Khan. Now I'm going to start unit number 3 in the subject Operation Research. Already 2 units I have completed. Unit number 4 I have completed Network Analysis. Unit number 5 I have completed 3 topics, that is Game Theory, Simulation and Queuing Theory. So after that, now I'm going to start unit number 3 that consists of 3 topics: transportation problem, assignment problem and traveling salesman problem. So if you want to get a complete command, watch all the videos from beginning till end. Then only you can be able to get complete command. Other than you have to keep the notes which I'm explaining. Simply watching the video, listening the lecture doesn't make any impact in your knowledge. So you have to work hard. You have to maintain the notes, and while watching the video always keep ready pencil, calculator, pen, notebook, etc. And if you have not watched the earlier videos, I suggest you to go to the playlist of my channel, select the subject Operation Research, select the videos which you want on different topics of Operation Research. Watch the videos, be acquainted, be confident on the subject. So before starting the topic transportation problem, take the screenshot of the points which I have written on the board. Then I'll explain what is transportation problem. Now, transportation problem. See here, transportation plays a very important role in any economy, and particularly in business decision making also. Actually, business consists of production and distribution. Simply producing the goods will not be sufficient. The business is not complete simply by producing the goods. After producing the goods, it has to be marketed. It has to be sent from the place of production to the place of consumption. And this transfer of goods from the production place to consumption place will be done with the help of transportation. Suppose if the production is good, but there are constraints in transportation, then definitely business will suffer. Business will not be successful. So transportation is very, very important in any economy, right? Now, rather than to cover the entire field of transportation problems, we are focusing only in one type of problems of transportation. Which type of problem? The transporting the goods from the place of origin to the place of destination, where the goods are produced and where the goods are required. So simply we will focus only on this type of transportation problem, not the entire field of transportation problems. That means movement of goods and services from one place to another place, so that the cost should be minimized. This type of transportation problem usually involves physical movement of goods and services from various supply origins to multiple demand destinations. In such a way, the transportation cost is minimum. This paragraph is very important. So what is the meaning of this transportation problem? It is concerned with finding out how many units should be transported from the place of origin, supply origin, and to the place of demand destination. The 2 places we have, supply origin and demand destination. So how many units should be supplied from which supply origin to which demand destination, so that the total transportation cost is minimized. Our objective is to minimize the cost. We want the schedule, how many units should be transported. For example, here with the help of an example, I am going to explain you. A tire manufacturing company has M factories located in N different cities. Factories are there, M factories are there, and in different cities there is a demand. So we have M factories and N demand destinations. At different parts the company is having factories. The factories will produce the goods and supply to the demand destination. Transportation determines the transportation schedule that minimizes the total cost of transportation tires from various factory locations to various retail dealers. So we have our company is tire manufacturing company. We have M factories at different parts of the country. Now we have many dealers who want the tires. So we have to supply the tires from the factories to the dealers. Many dealers are there and many factories are there. We want to find out a schedule so that we can be able to know how many units of tires will be transferred from each of the factory to each of the dealer so that the total transportation cost will be minimized. This is the example of transportation problem. Now next is transportation model. How to put this transportation problem in a model so that we can be able to easily solve the problem. Transportation model deals with the transportation of a product manufactured at different plants or factories, supply origins, to a number of different warehouses, demand destinations. So throughout the chapter you have to remember that places are there. One place is called supply origin and the other place is called demand destination. We don't have unlimited supply and we don't have unlimited demand. Demand and supply both have constraints. Within those constraints, we want to find out how many units should be transported from the factories to the dealers or warehouses. The objective is to satisfy the destination requirement within the plant capacity constraint at the minimum transportation cost. This is very important. The objective is within the constraints of the supply, we have to satisfy the demand requirement of the destinations. Example, the wholesaler will have a demand of 1000 tires and we have to see what is the supply of each of the factories. So we have to find out the schedule that we want to satisfy the demand of warehouses within the constraints of the supply so that the total transportation cost should be minimum. Transportation model thus typically arise in situations involving physical movement of goods from plant to warehouse, from warehouse to wholesaler, from wholesaler to retailer, from retailer to customer, etc. A chain is there. One place is the supply, another place is the demand. So we have different suppliers and different demand destinations. Solution of transportation model requires the determination of how many units should be transported from each supply origin to each demand destination in order to satisfy all the destination demand while minimizing the total cost of transportation. Ultimate objective is to satisfy the demand requirement from the supply origins so that the transportation cost is minimized. This is the model. It is called transportation model. So far I have explained you what is transportation problem and with an example I have explained then what is transportation model. Now next thing is solution procedure for transportation problem. This is very important. See here, if you understand clearly the meaning, the concept of transportation problem, then it will become easier for you to solve the problems. These are the fundamental foundation for the chapter. So don't ignore this, watch till the end. Now, solution procedure for transportation problem. How to solve? What are the steps involved? First of all, conceptually, the transportation problem is similar to the simplex method of LPP, linear programming problem. That will do it in unit number 1 and unit number 2. So far, we have not yet started. In that, I will explain you what is linear programming problem and what are the methods. One of the method in LPP is simplex method. Simplex method means first we find an initial solution. That initial solution is the basic first solution. We will find out whether it is optimum or not. If it is not optimum, we modify, again we test to find out whether it is optimum or not. If it is not optimum, again we modify and then check. So this iteration process will continue until we reach the optimum solution. This is the simplex method. Same procedure, simplex method of LPP will be applied in transportation problem. So we begin with an initial feasible solution. First, we need to find out initial basic feasible solution. But this solution may or may not be optimum. This initial solution may or may not be optimum. The only way one can find out is to test it. After finding out an initial solution, we have to test whether it is optimum or not. In majority of cases, it is not optimum. Then we have to modify, we have to change our allocations, our schedule. Then we have to test it again. If it is optimum, well and good, we reach the optimum solution. Suppose if we have not reached the optimum, we have to test it. If it is not optimum, again modify the schedule, again test it. So, if the solution is not optimum, it is revised and tested repeatedly. Repeat, we have to, same procedure we have to repeat again and again to reach the optimum solution. Each iteration should bring close to the optimum solution. That means whenever we are testing and finding it is not optimum, we are modifying. So every modification will bring the solution very much close to the optimum solution. That means every iteration will give you a better solution. Now, the problem is solved in general by using the following procedure. What are the steps involved in solving a transportation problem? The first step is define the objective function to be minimized with the constraint imposed on the problem. First of all, there is no good solution for a bad problem. First of all, you have to construct the problem. How to construct? What is the objective? What are the constraints and what are the costs? That means the complete ingredients of the problem we have to collect. Without having sufficient information about the problem, we cannot try for solution. The objective is to minimize the cost. So we need all the cost required, all the cost incurred to transport one unit from the place of origin to the place of destination. Similarly, what are the constraints available for supply and what are the constraints for demand? Secondly, set up the transportation table. After making the objective clear, then make a model. Model means a table will be prepared where the rows will consist of supply. The supplies will take it in rows. If we have only one supply and one demand, there is no question. There is no question of transportation problem. Transportation problem will arise whenever we have two or more than two supply origins and two or more than two demand destinations. So we take the supply origins in rows and demand destination in columns. The matrix will be prepared by rows and columns. So here row represents the sources, plants, factory, etc. and n columns represent the destination, warehouse, stores, market, etc. The origins are the factories and the demand destinations are the warehouses. So how many factories are there in the rows and how many warehouses are there in the columns? That will take. Develop an initial feasible solution to the problem. After making the table, the next step is make an initial solution, initial feasible solution. Different methods are there for finding out this feasible solution. In the coming problems, I'll explain you what are the methods available for IBFS, initial basic feasible solution. Examine whether the initial solution is feasible or not. The solution is said to be feasible if the solution has allocations m plus n minus 1 cells with independent positions. This is very important. The initial solution which you got is feasible or not feasible. For that you have to make a test. The number of allocations made in the table should be equal to m plus n minus 1. M stands for number of rows, n stands for number of columns, minus 1. If these many allocations are there, then it is feasible. And the allocations should be at independent place. independent place in the table. So if the total number of allocations in the transportation table is m plus n minus 1 and at independent positions, then we can say the solution is feasible. If the number of allocations are not m plus n minus 1, it is infeasible. So if infeasibility is there, then we have to overcome that infeasibility, make it feasible, and then only go ahead. How to convert that? Again, we'll do it in problems. Now test the cells having allocations are known as occupied cells, and the cells which we don't have allocations are called unoccupied cells. So after making this initial solution, we can see in the table some cells are occupied, some cells are unoccupied. Now test whether the solution is in step 4 is optimum or not. This is done by computing opportunity cost of associated with empty cells. Positive opportunity cost for all empty cells signifies optimum solution. So after making initial basic feasible solution, now we want to test whether this initial solution is optimum solution or not. For that, we need to calculate opportunity cost of unoccupied cells. Opportunity cost of unoccupied cells. If all the opportunity costs are positive, then we reach the optimum solution. If any one of the cell is having negative opportunity cost, that means this solution is not optimum. We have to reschedule. We have to change the allocations. Again, repeat the steps in finding out all opportunity cost. If all opportunity costs are positive, we reached the optimum solution. That's it. Now, if the solution is not optimum, modify the shipping schedule including that empty cell. By including that empty cell whose inclusion in the program results in largest saving. So if you find any opportunity cost as negative, reschedule, change the allocations so that the empty allocation earlier, now it will be occupied. By doing this, what will happen? The total transportation cost will further decrease. Now repeat steps 5 and 6 until an optimum solution is obtained. Now repeat. As long as we do not get the positive opportunity cost. So till we don't get all opportunity cost are positive, repeat all these steps. Once we get all opportunity cost are positive, we reach the optimum solution. That's the end of the problem. Now, methods of finding out an optimum solution of TP will consist of main steps. See here. Whenever we are solving the problem of transportation, 2 steps are involved. The first step to find out the initial basic feasible solution. In short, we call it as IBFS. Initial basic feasible solution. This is the first solution, first step. After finding out IBFS, then to obtain an optimum solution by making successive improvement to IBFS until further decrease in transportation cost is possible. Once we get the IBFS, now we have to test for optimum solution. If all the opportunity costs are positive, we reach the optimum solution. If we get negative opportunity cost, reschedule, change the allocations, again apply the test, again find out the opportunity cost. In this way, we can be able to get the solution of transportation problem. So in this video, I have explained you what is transportation problem with an example, what is transportation model, and what is the procedure of solving a transportation problem. Next video also I am going to explain you the theory regarding what are the methods of finding out IBFS and what are the methods for finding out optimum solution. See here, if you understand this theory, then only the problems will become easier. Otherwise, if you directly go to the problem, that means you are constructing a building without foundation. Can you imagine a multi-storied building without any foundation? It will collapse. The same thing will apply in understanding the problem without knowing the theory. That's why you must have a complete conceptual clarity on the theoretical concept. So if you're satisfied, give a like to the video, share my channel among your friends, among your group, so that more students can watch the video and enhance the knowledge. Give your comments, subscribe my channel if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, we'll continue our discussion on transportation problem in the next video.